Now that we have discussed about various properties connected with parallel lines, now let's see the reverse process of understanding the same properties. Parallel lines connected with reverse process. So what is this reverse process? Say for example, we have discussed in the previous session that when two lines are parallel, their corresponding angles are equal. Now my question is, if the corresponding angles are equal, will the lines be parallel? So we are investigating now in the reverse process. Imagine I take two lines which are not parallel. Say I take two lines somewhere in this manner and I just take a transversal out here. Then we know that there are 8 angles formed, 4 with L1 and 4 with L2. Now, when I say that the corresponding angles are equal, let's see if the lines are parallel. So as we know that the corresponding angles are same, that means angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8 must be same. So let's draw two lines randomly with the transversal and measure each of the angle, 1 with 5, 2 with 6, 3 with 7 and 4 with 8. So when we measure the angle 1 with the protractor, we should also equally measure the angle 5 with the protractor out here. Then let's see if the angles are equal. If the angles are not equal, then we can say that if the lines are not parallel, their corresponding angles are not equal. If the corresponding angles are equal, then let's take the case where the corresponding angles are equal. So here 1, 2, 3 and 4, 5, 6, 7 and 8. So let's take the case where the corresponding angles are equal. Then the property says that if the corresponding angles are equal, then the lines which follow that angle and the transversal must be parallel. If the lines are not parallel, then we cannot have the possibility that the corresponding angles are equal. Therefore, if the corresponding angles are equal, then the lines L1 and L2 must be parallel. This is how the property comes as converse of the lines L1 and L2 are parallel, the corresponding angles are equal. If the corresponding angles are equal, the lines L1 and L2 must be parallel. This is how the reverse process of understanding corresponding angles connected with parallel lines. Now let's see the reverse process connecting the alternate angles. As we know that when two lines L1 and L2 are parallel, their alternate angles are equal. Therefore, now let's investigate if the alternate angles are equal, will the lines be parallel? Reverse process of parallel lines, reverse process connected with alternate angles. Alternate angles. The lines L1 and L2 which are not parallel divided by the transversal and having the angles out here, we know that the alternate angles are 4 and 6. If angle 4 equals angle 6 and angle 3 equals angle 5, that is, if alternate angles are equal, then the property says that with the alternate angles being equal, the lines must be parallel. There is no other possibility but the lines L1 and L2 must be parallel. If alternate angles are equal, then the lines L1 and L2 must be parallel. That is, L1 parallel to L2 is how we understand the reverse process. If the lines L1 and L2 are parallel, alternate angles are equal. But if the alternate angles are equal, then the lines L1 and L2 also must be parallel. The reverse process of understanding alternate angles connected with parallel lines. Now let's see the reverse process of connecting interior angles with the parallel lines. Parallel lines in reverse process connected with interior angles, or in this case more specifically called allied angles, on the same side of transversal being called allied angles. As we have seen in the previous properties that if x and y are allied angles in the parallel lines L1 and L2, then x and y are supplementary angles. That is, x plus y must be 180 if x and y are allied angles, because they are interior opposite angles or interior angles on the same side of transversal. Now comes the question of reverse process. If the interior angles sum up to supplementary or sum up to 180, will the lines L1 and L2 be parallel? This is the biggest question out here. So let's investigate on interior angles connected with parallelity. Let's take two lines, L1 and L2. These two are the lines L1 and L2 divided by a transversal. It makes four angles, 1, 2, 3, 4, 5, 6, 7, 8 is how I get 8 different angles. Now we know that angle 4 and 5 are interior angles on the same side of transversal. Angle 4 and angle 5 and angle 3 and angle 6 are interior angles on same side of transversal. So let's see with the property that if angle 4 and angle 5 are supplementary and angle 3 and angle 6 are supplementary, then the reverse process says that given the condition that interior angles on the same side of transversal are supplementary or the sum is 180, then L1 must be parallel to L2 is how the condition states in parallelity. So the reverse process holds for corresponding angles, alternate angles, and interior angles on the same side of transversal, that is for allied angles. Is how we understand the reverse process being true for all the three connected angles for the parallel lines L1 and L2.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.